What's up, my friend? So this video it will be a continue of the previous video where we learned how you can create a simple function. Alright, and in this video we'll continue our learning, and we are going to enter a funny part, which is how you can create local variables in a function. And this is the funny part, and there is a lot of things happened here, and here the real work happen. Alright, let's get started. You have our section.text, normal routine, then our global start like this, then our start label. Alright, and don't forget our done label. So move rx16, our exit syscall, then move rdi 0, then our great syscall like this. Alright, good. Now let's go to our whiteboard, which is black. Okay, so let's imagine this is our stack like this. Alright, so as we said, we have some data here, some data, then it happened the call. Alright, so let's try to imagine it. Alright, for example, we have a work here, move rx0, move rbx1, blah blah blah, then we call our add function, for example. Then what we need to do, we need to do add and 2 points and the code of our function. But let's take a moment and let's do a recap about what happened when we do call add. As we said, the CPU or the program or the PC in general, or let's say the CPU to be more technical, right, it's needed like to know where I'm going to continue my work. For example, if I have here move, for example, r10 0 like this. Alright, he should know when he will end the function, and like when the function will end, he need to know where to come back. Alright, so he is saving the next instruction address in the stack. So when we do call, the first thing that the CPU do is saving the address of this line. Alright, so and which is named the return, or let's type it. Alright, so let's type it right here, return address like this. Let's make it small like this, and good. Alright, so first thing that the CPU is pushed in the stack is the return address to know where we are going to continue our code. Right, good. Then here, as we said, each function in the world have a stack frame in the stack. Right, for example, let's imagine this is the stack frame of the add function, and you are going to ask me like how the stack frame is generally created, like how we are going to know the start and the end. And as we said in the previous video, there's two registers, RSP and RBP. Right, so RSP like this, I am terrible at drawing, then RBP like this. Alright, so these two registers, they are or they have the roles of controlling the start and the end of each function in the stack. Alright, the RBP, as we said, is the base of the stack frame of the function, so he is always in the base, like he is like saying, I am the base of this function, I am the base of this house. Alright, so it's always in the start of the function. For example, here this is the stack frame of the function. The RBP will always point right here, so RBP is going to point right here, and we are going to see how we can make the RBP point in the start of the function. Then the RSP take the role of like knowing when this function, the stack frame function, will end. So the RSP, we are going to see it always point right here, but you should know the RSP, this is not his only work. His work in the base, he is pointing to the last data or the last element pushed in the stack. For example, let's move right here. Okay, so let's do this. For example, let's say you pushed, for example, 0 1 0 in the stack, so the RSP will point right here. So for example, let's say the RSP was pointing right here, then we are going to move this, and the RSP will point to the last element or the last data pushed in the stack. So this is the role, so this is the base role of the RSP in the stack. Okay, good, let's continue. Now here, as we said, we know how the stack frame is built from the basic, and let's continue. All right, let's remove all this and let's continue. All right, so as we said before executing our program, the CPU or the stack is working normally. All right, we have previous functions and they have also the RPP, the stack frame. So let's say the RPP was pointing to here, for example, RBP. Let's do this. I am terrible at this. But let's continue. All right, so let's say the RBP was pointed right here to ensuring or to saying that this is the start of a function. All right, good. Now what we need to do, we need first to save this old RPP, because when this function will end, we need the RPP to come back to its place. All right, so what we are going to do, we will push this old RPP right here, but let's make it more simple. The RPP is put right here. What it means he is holding the address of this place in the stack. Alright, so in other way, we are going to save the address of this place in the stack right here. So in other way also, we are going to do saving the old RPP. I hope you understand it. And if you remember, as we said, whenever time we push something in the stack, the RSP points to that something. Right, so the RSP, whenever he is right now, so for example, let's say the RSP is pointing right here. Right, for example, let's make it was pointing right here, then this RSP will not be pointing right here anymore and he will point right here. So let's remove also this. Good. The RSP will point right here. Good. So now we are safe, the old RPP is saved in the stack. Now we need to make the start of the function. Just to know, we didn't start our stack frame of the function, we just saved the old RPP and the RSP point right here. Alright, so now we need to make the RPP, the register RPP, point right here. So what we're going to do is just make the RPP point where the RSP is pointing to. Alright, because the RSP is already pointed to the last element pushed in the stack. Alright, so we're going to make the RBP point right here. Good. Now let's continue. Now what you need to do, we need to save data, or to save space, which is in other way bytes, for our local variables of this function. So what you need to do here, we are going to take a break and explain something. The stack is how I can explain that. He is flipped. For example, we know we start from the low address to the high, but here in the stack the reverse. He is starting from a high address, alright, and he is going down to low address. So let's do low address. Alright, so to move down, we need to move by subtraction values or subtraction address. So the RSP, to make him point right here, to save this data, to make it local to the add function or any function, we need to do RSP minus the bytes that we need to reserve for this function. For example, let's do, we want to reserve, for example, 32 bytes, right? So 8 plus 8 is 16, plus 8 is, I guess, 21, plus 8 is 32. So here it will be our stack frame of the function. How or why? We are going to do RSP minus 32, sorry. All right, 32. I am terrible at calculation, so let me use this. So 8 multiplied by how? By 1, 2, 3, 4. So by 4 is equal to 32. Good. All right, let's continue. So as we said, we reserved our bytes for our function. Good. I just want you to know this information, right? This number here, as you can see, that we are going to subtract from the RSP, need to be a divide. It can be divided by the number 16. That's it. So if you were in a 64-bit machine, this number here must be multiplied, or it can be also divided by 16 right? Because it's something called alignment. So the CPU need the RSP to be in an address that it can be divided by 16. All right, I hope you understand this, but just you should know it, and that's it. All right, good. Let's continue. So now we understand how we can make a stack frame of a function. Okay, now we are going to do something special. We are going to make two functions, and inside the first function we are calling the second function, alright, to make it more special. Alright, so for example, we are doing some code here, move rbx10, and abracadabra, we are calling our call. For example, let's call our main function, like in C developers, I see you. Right, so I'm going to call our main function. Good. Let's go down here and call our main function like this. Good. So let's do a recap. First thing, push RBP. Good. Let's do a comment here, saving the old RBP from the previous function. Good. I am very sorry for my English. Okay, now second thing, as we said, we need to make this RBP point where the RSP points, because the RSP now is pointing to the last element pushed, which is the RBP. Alright, well, let's name it the old RBP. Alright, so move the value in the RSP in the RBP, creating the base of our function stack frame. Good. Let's continue. Then, as we said, what we need to do, we need to save some byte or some space for our local variable of our function. Good. So we're going to subtract RSP from a number, and this number, as we said, it needs to be divided, or it can be divided by 16. So the RSP is the stack pointer, so he is pointing to the last element, or let's say the last element pushed in the stack. So we need to make him point lower. Alright, so to make some space. I hope you understand, or you can imagine this. Alright, and as we said, it's like this. It's make him like point right here, so this space is gonna be reserved for this function. For example, in this case, the function is let me draw this, is main. Good. Let's continue. So RSP, for example, as we said, we want to reserve how many bytes. For example, let's say I want to reserve how many bytes we reserved here? 1 2 3 32 bytes. Alright, so how many variable we have here? One variable, 2 3 4. Alright, so 32 bytes. Okay, now let's continue. So we're going to do, let's close this and let's continue. Alright, so 32 bits, or let's say here saving some space in the stack for the local variables of the function. Good. Now we can simply start our function. Alright, good. Now you are going to say, or you're going to ask me like, how I can access this space right here? As we said, this will be our base of our function. So by this RBP pointer, we can access each variable in this space right here. Okay, alright. For example, let's say we want, for example, to access. Alright, so for example, let's say we are going to save 3 variables in our main function. Alright, for example, let's say we have here our main function, we have, this is our C code. Right, so let's say this is our C code like this. Alright, we have int a equal to 5, int b equal to 6, and our int sum. And now sum, I am terrible at this drawing, really. It's calling add. Let me write add function. So add and add take two parameters, taking E and B. Good. Now this is a good practice for you guys to understand function and the parameters and how we can pass parameter to our function. Good. Now we are going for example, let's continue. Let's make our add function. So for example, this is our main function and this will be our add function. For example, add function takes one variable like this, int C, and C is going to equal so for example, this is our main function and this is gonna be our add function. So for example, in add function we have int C is equal A plus B. Good. Let's type right here add, and here we have our main function. Good. Let me just draw this, or let's make this right here. Good. Alright, as we see, we have the RBP is pointing right here and RSP now is pointing right here. Good. Let's remove this RSP minus 32 and let's remove also this and this and this. Good. And let me just alright, like this. Good. This is our main function. Good. Let's continue. Now, as we said, we want to access our variables that we want to create, for example, right? So first thing, as we can see, we have an integers. An integers takes 4 bytes. So 4 bytes here and 4 bytes here and 4 bytes here. Let's remember this block in 64-bit machines takes 8 bytes, and here we are going to reserve in it 4 bytes because we are just beginners. We will miss some memory, or we are going to to use more memories for a small variables like an integer. Okay, just to get flexible with working with functions and variables in assembly. Okay, and in the future we are going to set exactly the size of this variable in the stack. Good. Let's continue. So to move out to this block of memory, we need to do RBP minus 8. So in the place where the RBP minus the offset, which is 8, do this or save this value. Alright, or save this value right here. Alright, let's do it. So we are going to move in the RBP with this parentheses minus 8. Alright, so move down to the empty next block of memory. Alright, and save the value of 5. But here we need to know something. We cannot just do this. Assembly need more details. What is the type of the data that you want to save in this block of memory? It is a byte, or a word 2 bytes, or a D word 4 bytes, or a keyword 8 bytes. Alright, tell me. Here in this case we have 5. 5 is not a byte, or it's not even a 2 bytes. It's a word. It's a D word, sorry. So it's a 4 byte, as we said. Alright, so here we moved 5 in this place. So we have here 5. Good. Let's continue. Let's draw it in a nice, bruh, come on. Good. I guess this is good. Okay, let's continue. Then to move to the next block of memory, we need to do move minus 8 minus 8. So move RBP minus 16. So the same thing, the word RBP minus 16 and our value, which is for example 6. Good. So here, as we can see, let's do this. we save the value 6 right here. Good. So now we have our two variables, and second variables have his place. So our third variable doesn't have any value, so we will not save anything right here. All right. Good, let's continue. Now as we can see, we have a calling, so we are calling the add function. So what we need to do, we need inside the function main call another function called add. All right, so let's do it. We are going to do here call add, but before this we can see that the call add need two parameters, and if you like remember the old video or the previous video about function, we need to pass the parameters before doing the call instructions. So what we need to do, we need to move in the RDI and in the RSI register, which is these two registers at the register that are specified in passing parameters in functions in assembly. Good. So we're going to do move please in the RDI register what this value. So we're going to also enter this block of memory and get the value from it and save it in the RDI register. So we're going to do RBP -8. Just to know, saving data need to specify the type or the size of this data, but receiving data from the stack doesn't need this more details. All right, just move it from the stack into a register. All right, then move in the RSI register the RBP -16. Good. So we have in the RDI register the value 5 and in the RSI register the value 6. Then we can do in a simple way call add. Now let's see what we have here. Alright, so as we said, when we do call add, what it say, what is the first thing saved in the stack? The return address. So here is gonna be save the return address. Let's type it. Alright, sorry, let's do here and let's type it right here. We have here return address. Good. But which return address? The CPU is a very smart computer. The CPU is very smart. He knows the next address, so he not save the address of this place. For example, let's say I'm moving R10 with 0 here, so this address here is the address of this next instruction. And for example, let's say we have here move R9 with 9. So now this return address have the address of this next instruction. Good, let's continue. Then as we said, we need what? We need to call our function. So we're going to go down here and call our add function. Just to know, we did not yet finish our main function. Okay, let's continue. So this is our add function. The same thing, we need to push RBP. So we're going to save the old RBP. Which is the RBP? This RBP right here. So now we're going to save this RBP that he is pointing to our previous function, which is the main. We're going to save it on the stack. Alright, so let's do it. We're going to do what? Old, or let's say, or let's name it the main RBP of fun main. I hope you understand this. Alright, so of fun main. Good. Now we save this address right here. Then what we are going to do, we are going to erasing this like this. This is gonna be erased, and the RBP we are going to make it not yet. Let's do it. Let's do move the value in the RSP in the RBP register. So as we said, when we are going to push in something in the stack, the RSP is going to point right here. So the RBP, we are going also to erase it, and it's going to point right here. So R is P, and at the same time the RBP is pointing right here. So RBP. Good, very good. Alright, let's continue. Now what we need to do, we need to set a stack frame. Good. As we said, we need to subtract the RSP to make it to point in somewhere depend on our size of our data. Alright, so we're going to do what? subtract the RSP from, for example, we need just one variable, but here we are a 64-bit machine, so the number, the RSP, or the number that we are going to divide the RSP from, needs to be divided by 16, so we're going here to use 16, right? Good. So the RSP is going to point here. No, it's going to point right here. So the RSP will point now right here. So RSP. Good. So RSP is going to point here. Let's continue, and we can work in an easy way like this, like in the beginning, in the function way. So we're going to take now our variables from our parameters. So we're going to move what? We're going to take the A and the B and sum them together and save them in the C variable. So we're going to move the word where in the RBP, let's do it, RBP minus 8. So this RBP minus 8 is the place, for example, let's imagine it is the variable C is going to be saved right here. So the word RBP minus 8 is going to take what? The value from the RDI, which is 5. So now here we have what? We have 5. So in the same block of memory, we are going to do add RBP minus 8, the value what? The value RSI. So 5 plus 6, which will give us, let's say, 11. Good. We have here, let's do here 11. Bruh, come on. Alright, 11. Good. Now we need to return this C variable, because this variable need to be in this sum variable. Alright, so what we need to do, we need to save in this value, or this from this data in the stack, in the REX register. If you don't know this, the REX register is work of the return value of any function in the world in assembly. Alright, just let's say not in the world, in assembly in this case. So in functions, the RX is the register that it have the role of returning the address from a function. So I'm going to do move in the RX register the value from RBP minus 8. Good. Then, as we said, pop the RBP. So it's like taking this. First thing we need to make. We need to make the RSP go up right here to erase this data. Alright, so we can do like, we're going to do add RSP, the data that we added, that we subtract from in the first, we need to add it right here to make the RSP go up, and this data is going to be erased automatically. So RSP is going to point again right here, right here in this place. RSP. Good. Let's continue. Then pop the RBP. Alright, so this RBP is going to be popped like this. So RBP, so this, let's do it like this. This RBP is going to be popped. Alright, then what we are going to do, we are going to see when we do RBP, pop RBP, the value that we removed from the stack is going to go into the RBP register. So RBP register is going to point again in this place. So RBP is going to go right here. So let me do it again. Let me do it again like this. Right, so the RBP is going to point right here. And what else? We're going to do return. Alright, so return is going to save, it's gonna like remove also this return address, and RSP is going to get back to his place. Alright, so RSP is going to point to here. Alright, good. RSP now is pointing right here, and then we can continue our function. So as we see here in the end sum, the sum is need to equal to the sum of these two variables or let's say the return value from the add function, and we're going to save it right here in this block of memory. So we're going to do move again in the d word, like move d word rbp minus what, minus 21. All right, so 8 16 21. Good, the offset. All right, what we are going to move, 11? No, the value from this function, which is saved where, in the rx register. So rx. Good. Then what we need to do, nothing. We end here, it end here. You have the return value, we can save it in the rx register again. We can save it here in the rx register. So move rbp minus 8, and again add rsp, the value here 32, then pop the rbp and return. That's it. You finished two functions in a simple, very simple way. I know we are going to face some problems and some sick faults, sure, for sure, but we are going to solve it. All right, so here in the call main we can do like this: save the rx value in the r10 register. Alright, now let's stop blah blah and let's go and let's run our program, alright, to see. Good, let's do a very quick recap. We pushed our rpp, move rsp in rpp, subtract 32 from the rsp register, move rpp minus 8, call add, save here, move. Okay, here we have move, push rpp, rsp and rpp, like this. Everything is going well. All right, and here let's don't forget to do jump done to end our program. Good, very good. Let's do Nazem. We have our problems. Good, yes, we have problems in the line 21. Error, mismatch in operand size. Good. Let's see in the line 21 right here. All right, so rx register is a register of size 64 bits, so it doesn't need, we cannot move. We are saying here we are moving 4 bytes and here we are moving 8 bytes. The rx register is equal to 8 bytes, so what we need to do here, we need to do keyword is equal to 8 bytes. We are saying to the stack that we are moving 8 bytes. Alright, and also right here the RDI register, it's an 8 byte register. Right, so we need to do keyword, and here also keyword. We have a second solution, and we're going to see it lately. All right, so Nazem, it's working. All right, ld run, no sick fault. All right, let's go here. So as we said, we are moving here d word, and d word is equal to what? Is equal, let's write it right here. D word is equal to 4 bytes. Sorry, 4 bytes. Easily we can just work with the 4 bytes register, which is the EAX. All right, so here also we can do the EDX, and here ECI, and just do D and D, and it's going to work well. All right, but for safety, let's just do RX to don't get confused. All right, so keyword, here also keyword, and here RDI and RDI. All right, here another keyword is equal to 8 bytes. All right, good. Now we are in the best part, which is the GDB. All right, so we're going to use GDB to see the stack and see the register and all of this. All right, so here I run our program, everything is going well. GDB our program. All right, breaking at the start, good, and do run, good. So here, as we can see, the RSP is pointing to 1, which is the argument counter, the argc. All right, and as I said in a previous video where I printed the argument, which is the argv, the argument of a program using assembly, the RSP in the first, when we execute our program, is pointing to the argument counter, which is in this case 1. Remember this. All right, let's continue. We have in like this. Okay, so we have here let's have move EBX. here we have our call main. Alright, now we are going to do si to dive into this function. Good. As you can see, the RSP now point to what? Point to the next instruction that is going to be executed, which is moving the value from the RX register into the R10 register. So if we remember, it means that we saved in the stack the return address. Good. Now we are pushing the RPP. Here we push the RPP. Now the RSP points to the RPP. So we are going to make the RPP point where the RSP points. So we set the base of our function. So next, ni. So here, as you can see, like this, it's a magic. Like here we saved space for our function manually, alright, by doing RSP minus 32 bits. Alright, then we have next instruction. We are moving the value 5 in this place, which is, I guess, right here. Alright, so next instruction, as you can see, we have here in the end of this 8 byte block of memory, we save the value 5. Good. Next instruction 6 right here. Then we are moving in the RDI register this value. So you can see in the RDI register we have 5. Then in the RSI register we have the value 6. Good. Now what we are going to do, we are calling another function, which is add. Here is the real magic. Si. Good. Now RSP, where he is pointing to the next instruction that is going to be executed, which is this. Alright, then we're going to push RPP. Now the RSP point right here. Then next, then we are going to make the RPP point where the RSP point to make a new stack frame function of a function. Right, so we are saving some value. As we said, 8 plus 8 is 16. Then we are moving this value right here in the first 8 bytes block of memory. Then in I, we are saving like this. Then here we are saving our return value in the RX register, right? Then in I, we are adding the ISP to make to clear the stack, then popping the RPP, like taking the old RPP and saved in the RPP register. Alright, and so the RPP is returned to his place. Then the ISP is going to return in his place when we are going to pop out this instruction right here, which is the return address. So the ISP return back to his place, and we're going to execute our main function normally. Alright, ni like this. Then we're going to do another ni, and we're also clearing the stack by this instruction. We're adding the same value that we do it in creating our stack frame function, ni, and popping the RBP and popping also the return address, and we are moving the return value in the R10 register, and our code is done. I really loved this video. I guess this is the very funniest video I did in this channel. I hope you enjoyed, and I hope making another video funny like this. Alright, so see you in the next video. Peace.